All right, so now let's do an example of how to use this. So if we want to find the slope at point P, we need to do that long formula. So m equals f of x plus h minus f of x all over h. But we need to do that as the limit as h goes to 0. I'm really good at forgetting to write the limit thing in. It's really important. Don't forget it like I do. All right, so f, excuse me, f of x plus h, we'll just plug that in. I've got to erase what I already started because I need to add limit as h goes to 0 of f of x plus h. So I got x plus h squared, right? That means just put in x plus h wherever you see x into the function, minus f of x, that's just x squared, all over h. All right. So we're going to go ahead and plug that in. Or excuse me, do some simplifying. H goes to 0. X plus h squared is x squared plus 2xh plus h squared, all minus x squared, and then all of that over h. All right, so now we're going to do a little trick here. We're going to limit as h goes to 0 of x squared minus x squared. They cancel, so I'm going to not have to even write that. And then we're going to look at the top. Do you see that there's an h that factors out? So it's going to look like that if I factor it out. And then notice these h's magically cancel. Yay. So the limit is 2x plus h. But if I put in 0, because you can substitute, I get 0. And now my x is 2. So let's put it in. 2 times 2, 4. My rate of change at the point 24 is 4. Another way to do that same exact problem is to think of, so remember it was x squared equals f of x at p 2, 4, and we want to find the slope or the instantaneous rate of change, same difference, is to use that same formula, f of x plus h minus f of x all over h. The limit, see, I'm really good at reading that. Limit as h goes to 0. You need that there. It has to be there. It's not what slope is. All right, so the slope at that point is given by the limit as h goes to 0. Now, you could say, all right, well, I know what x is. Okay, I'm looking for f of 2, so I'm going to put in my 2 now. I need to do f of 2 plus h minus f of 2 all over h. Oh, I forgot my limit again. Limit as h goes to 0. I'm good at forgetting that, but it's really quite necessary that if it's not there, it's not the same thing as if it's not there. All right, so if I do that, I already know the x. I just maybe save myself some steps at the end. However, if you have lots of points where you want to find the various rates of change at 5 or 6 points in your graph, it might be better to do the way I did it in the last slide, and then substitute in your x's, and you can get them all from the same equation. In this one, if you just have to find it at one point, it might be easier math to do it this way. So I'm going to plug in this for x, 2x plus h. I'm already trying to forget my limit thing. Limit as h goes to 0. Minus f of 2, so 2 squared, all over h. And I think you're going to see that my math is a little bit easier. So I have 4 plus 4h plus h squared, because you have to FOIL that. So remember, that's 2 plus h times 2 plus h. So if you don't believe me, that's how I did it. That's how I got the 4 plus 4h plus h squared. FOIL it out. Minus 4 all over h. Now notice that these 4 and minus 4 simplify, they cancel. And so on the top, let's see, I still have my limit as h goes to 0. Factor out an h, 4 plus h, all over h. Now, honestly, I don't actually do that. I notice that an h will cancel from everything. Its division is distributive, so I divide by everything by h. So that's how I really do it, but I think a lot of people have a hard time seeing that or doing it correctly. So there we go. And so we're really finding this limit because the h's cancel. I could have just gone ahead and substituted it in, but I still get 4 if I do it that way. So that might save you some steps. Some of the math might be a little easier for you. So if you know the value of x right away, or you only have one value of x to find, it might be faster just to substitute it in before you start the limit. But if you have to find several values for slope at different points along the curve, the parabola in this case, it might be better to find the generic slope and then substitute in each of your values for x and find all the slopes from there. All right, so we want to find the equation of the tangent line to the parabola at 2, 4. And the equation of the normal line. Well, we said that we just found the slope in the last example to be 4. So we want to find the tangent line. Well, the slope is 4. And here's the point I go through. So y minus 4 equals 4 for the slope, okay? That's my y2. I'll put that in over here. All right, equals x minus 2 minus x2. I said y2, x2. It doesn't matter, as long as you call them the same thing. All right, so now what's the equation of the normal line? Remember, normal line is just a fancy word for perpendicular. Orthogonal line is also a word for perpendicular. Our book uses normal line a lot. So remember, perpendicular lines would have a slope of the opposite reciprocal. So it is almost going to look exactly the same as the tangent line, except my slope is going to be negative 1/4 because opposite reciprocal, and x minus 2. So that's the only difference. And no need to change it to y equals mx plus b because it just said right at the equation. It doesn't say what form it has to be in. That's good enough. All right, we're going to do another example, but AP, you're going to be a lot of examples. At some point, you might want to take a break. Regular, I think that you probably want to listen to these because it seems like people struggle with this. All right, so find the slope of the curve at x equals any a. So remember, slope at any point is the limit as h goes to 0 of f of x plus h minus f of x all over h. Now, I'm doing this at x equals a, so I'm going to go ahead and put that a in for x, kind of like I showed you the other way to do the last problem. So I'm going to do, instead, f of a plus h minus f of a all over h. All right, limit as h goes to 0. So limit as h goes to 0. Now that means I'm going to put an x plus h anywhere I see x. A plus h, I think I might have said x plus h, squared minus 2. Okay, so that's f of a plus h minus f of a. Let's see, put a in everywhere I see x. All over h. Limit as h goes to 0. All right, so I still have to do the limit as h goes to 0. I'm going to FOIL this guy out, so a squared plus 2ah. So remember, that's because I have to do a plus h times a plus h. If you FOIL that out, a squared plus ah plus h squared, that makes 2ah right there, so that's where I'm getting that, plus h squared minus 2. All right, that's the f of a plus h. Now I still have to do the minus. Now I have to distribute. This is like a coefficient of 1, so it's like a negative 1 that distributes. So negative a squared plus 2. Another way to think about that is it's not just subtracting a squared, it's subtracting negative 2 as well. So it has to change that sign. Still all over h. Now notice that a squared and the minus a squared are going to cancel. The minus 2 and the plus 2 are going to cancel. And basically, you've screwed something up if all your terms that are left don't have an h in them, because you want an h to cancel, because you got to get rid of that dividing by h. You can't do limits when you divide by 0. So I'm going to factor out an h from the top. I usually honestly skip that step, but I'm trying to make it painfully obvious that they cancel. So now I don't have dividing by 0, so I can substitute. You know, limits are easy when you can substitute. So I have 2a plus 0, or just 2a. So basically what this is saying is this is the slope at any a. Now, slope is not 2a. It's 2 times whatever the value of x is. Okay, so we called x a. But a slope is a number. That means I have to know what the a is and find out the actual number for slope. Slope is a number. So that's the slope at any x I want, or any a I want, any x value. So let's find the slope of the curve at x equals 2. So we said slope is 2a, and we said x equals a. So really it's saying that a is 2. So the slope is 4. All right, so the equation of the tangent line would have a slope of 2. And my y value, remember, so if we're talking about y equals x squared minus 2, if x equals 2, my y value is then 2. Okay, so we're talking 2 comma 2. We're going through 2 comma 2. So my equation of the tangent line at 2 comma 2 with a slope of 4 is y minus 2 equals 4 times x minus 2. The normal line would just have the opposite reciprocal slope, but it still goes through this darn point. So it's going to look almost exactly the same, except the slope will be different. And it says, where is the slope 6? Well, we know slope is equal to 2a. So, and the a is really just another word for x. I often don't put the a in, but your book uses that, and I wanted you to see it. So I want to know, remember this is the slope, so I want to know where the slope is 6 for what x value, or since we changed x to a, what a value is slope 6? Well, negative 3 is a, which remember is really just x. So when x is negative 3, that is where the slope is negative 6. So at negative 3 comma would be 9 minus 2. Great. 9 minus 2. So 7. At 3 comma 7, the slope is negative 6. All right.